Hello and welcome. Today we'll be solving the question above. All right, we'll be drawing the shear force and the bending moment diagram. So for us to solve this question, we are going to be replacing these two supports by just a upward force, that is an upward reaction, since we don't have any horizontal load. All right, so for us to do that, we are supposed to redraw this diagram. Then we are going to be replacing this support, you understand, these two supports with an upward, that is reaction at A and the reaction at B. But I will not be doing that. I will not be doing that. I'll just do like this. I'll just put the reaction below them to show that there's a reaction at A, and here to show that there's a reaction at B. I'm just trying to manage my space. All right. So now let's get started. Now for us to solve this question, we are going to be starting with summation of upward forces must be equals to what? 0. So we are going to say the summation of upward forces is equals to what? 0. So here we are going to take coordinates. Upward force positive, downward force negative. All right. So it shows that arrow A plus arrow B, arrow A, arrow subscript will be equals to, now if you look at these two forces, they are the only upward forces that we have. So the rest, they will be acting as a what? Downward forces. So it's either you say minus or you just say equals to anyone you are saying. We are still at the same line. All right. So this will be equals to, now let's start with this downward force here, 7.5. 7.5 plus, all right. Now if you look at this, we have a uniformly distributed load here. So which we need to convert to a what? A point load. So converting to a point load is going to act what? Is going to act at the center of what? F and what? And B. So for us to convert it to a point load, we are going to multiply 7.5 by the total distance it covers. If you look at the beam, if you look at the uniform distributed load, the load, it covers B, point B to what? Point F. So it means 7.5 multiplied by what? By 4. So we are going to have 7.5 multiplied by 4. Then plus what? Plus 7.5 multiplied by what? By 2. 7.5 multiplied by 2. All right. So this R subscript A plus R subscript B, this reaction at A plus reaction at B will be equals to 7.5 plus 7.5 multiplied by 4. That is what? That is 30. Plus 7.5 multiplied by 2 is 15. All right. So 30 plus 15, that is 45. And 45 plus 7.5 is 52.5. So we are going to have reaction at A plus reaction at B to be equals to what? 52.5. So we can call this equation number what? 1. All right. So the next thing we are going to be doing is we are going to be taking moments about what? About A. So we are going to be taking our moment about point A. So we are going to have this to be arrow B multiplied by the total distance to A. So we are going to have arrow subscript B multiplied by what? The total distance here is going to be what? 5. All right. So again, we are going to take the moment about point, from this point to this point. So we are going to have minus 7.5 multiplied by the total distance it covers to this point. That is 2, 4, 6, and what? And 7. 7. All right. So now if you consider this uniform distributed load here, 7.5. 7.5 multiplied by 4, that is 30. So we are going to have minus 30 multiplied by the distance. Don't forget, it's going to act at what? Half of this distance. So it's going to be 2 plus 1, that is 3. All right. All right, don't forget, we also have a moment here at point D. And the moment is going in a what? Is going in a what? Is going in an anti-clockwise direction, right? And we said that our upward force is positive, right? And our upward force is going to give us a what? Is going to give us what? An anti-clockwise moment. So it means that that is going to be what? Plus 15. All right. Now again, if you come to this side now, you come to this side. This is our point A, right? Now, and this is the uniform distributed load. So we are going to take this moment now about this point now. We are taking it about this point. All right. If you want to do that, 7.5 multiplied by 2, that is 15, right? So, and this moment now, this moment that we are taking is going in what direction? It's going in a what? In an anti-clockwise direction too. Is that clear? It's going in an anti-clockwise direction. And this moment here is going the same direction with this moment that is here. So with both of them is going to be what? Positive. Please take note of that. All right. So 7.5 multiplied by 2, that is what? 15. And it's going to hurt at what? Half of the line, right? And 2 divided by 2 is 1. That is 7.5 multiplied by 2, then multiply by 1, which is going to give us what? Which is going to give us 15. Everything will be equals to what? 0. All right. So now here we are going to have 5 times ROB. That is 5 ROB. Then minus 7.5 multiplied by 7. So let's just take everything to the other side. So this will be equals to 7.5. 7.5 plus 7.5 multiplied by 7. Then if you take it to the other side, you are going to have 52.5. All right. And 30 multiplied by 3, that is what? 90. If you take it to the other side, it's going to be positive 90. All right. 15 plus 15 is 30. If you take it to the other side, you have minus 30. All right. So now 52.5 plus 90. 50 plus 90 is 1. That is 142.5. 142.5 minus 30. You are going to have nothing but what? 112.5. 112.5. So it means that 5 ROB is equals to what? 112.5. So if we divide both sides by 5, then our R subscript B now will be equals to 22.5. All right. So that is the value for what? Our ROB. So we can therefore get our ROA now. So our ROA will be equals to what? Our ROA will be equals to, if you take our ROB to this side, from equation 1, we have 52. So it's going to be 52.5 minus ROB, which is what? 22.5. So 52.5 minus 22.5. We are going to have what? We are going to have 30. So this is going to be equals to what? 30. Plus, don't forget the unit. It's going to be in what? Kilonewton. This is going to be in what? Kilonewton. All right. Now that we have gotten the reaction at the support, now we can therefore go for the what? The analysis of what? Shear force. That is the shear force calculation. So let's start with the shear force. All right. So we are going to be starting with the shear force calculation at point C. Again, we are still using our upward force positive and our downward force negative. So the shear force at point C will be equals to, now if you stand at point C and you look to the right, the only force we have there is just the this force here. So it's going to be what? Minus 7.5 kilonewton. All right. So again, we are going to go to the shear force at point B. Shear force at point B will be equals to what? It's going to be equals to what? The reaction at point B, there and this. So that is just the two forces we have there. That is, if you stand at point B and you look towards your right, you only have this force and this force. So it's going to be what? 22.5 minus 7.5. 22.5 minus 7.5. All right. So 22.5 minus 7.5. That's going to give us this to be 15. So I'm going to have 15 kilonewton. All right. Yes, that's 15. All right. So now the next one is the shear force at point B. So shear force at point B. All right. The shear force at point D rather. All right, the shear force at point D is nothing but what? is nothing but RB minus what? Minus 7.5. Then, because if you start at point D, we have a what? We have a uniform distributed load here. So let's just take that one after the other. So we are going to have our RB. What is our RB? We have our RB minus what? 7.5, which we've already gotten here to be what? 15. So we are going to have 15 minus, then if you look at between point D and B now, we have a uniform distributed load here. So which we are going to convert to a point load. 7.5 multiplied by 2. That is what? 15. And it's going to act at what? The center. Do you understand? But we just only need the force here. So between D and B, we have a uniform distributed load. If we convert that to a point load, that is what? 15. So we are going to have this to be minus 15, which is equals to what? 0. So that is going to be the shear force at what? At point D. All right. So let's go for the shear force at point F. The shear force at point F. All right. We've already do the shear force from point C to point B to point D. So if you do that, this is our point F, right? Now, if you do this, we are going to have ROB minus what? 7.5 minus what? Minus 7.5. So if you do all of this, you are going to get 0. Do you understand? So now 0 now minus what? Minus, we only have uniform distributed load between point D and F. So that is 7.5 multiplied by 2, which is going to give us what? 15. So we are going to have 0 minus 15 here, which is going to give us what? Minus 15. All right. So don't forget kilonewton. Kilonewton. All right. So now we are going to come to point A now. The shear force at point A. All right. So the shear force at point A is the same thing as saying we are going to, if you stand here, this is all the force we are going to see, right? So we have gotten the shear force from this point to this point F to be what? Minus 15. So now we are just only going to add this other one there. It's going upward, and we said upward force is positive. So here we are going to have minus 15 plus what? The reaction at RA is nothing but what? 30. So it's going to be minus 15 plus 30. That is what? 15 kilonewton. All right. So the last but not the least is the shear force at E. All right. The shear force at E. So if we stand at point E here, we have already gotten the shear force from point C to point what? To point A to be what? 15. All right. So this is our point E here, and it's having a uniform distributed load, which if we convert it to a point load, 7.5 multiplied by 2, that is what? 15, right? So, and then we are going to subtract that because it is a what? A downward force. All right. So we are going to have 15 minus 15 to be equals to what? 0. All right. So we are done with all the shear force calculation. So now let's go to the bending moment calculation. So bending moment calculation. All right. So now let's start with the bending moment at point C. So the bending moment at point C is what? 0. Because if we stand at point C to your right, we don't have any distance there. So that will be 0. All right. So now let's stand at point B now. The bending moment at point B. Bending moment at point B will be equals to, now if we stand at point B, we're going to have this force, then multiply by the what? The distance. And don't forget, this one is a downward force, that is negative. So negative 7.5 multiplied by 2, we are going to have negative 15 kilonewton meter. All right. So now the next one is the bending moment at point D. All right, the bending moment at point D. All right. So if you stand here, what are we going to have? We have this in point B. You have to be careful with point D. Now look at this. Negative 7.5 multiplied by total distance. That is negative 7.5 multiplied by 4. Then we now have ROB multiplied by what? By 2. That is plus. And our ROB is what? 22.5 plus, because it is upward force, 22.5 multiplied by what? By 2. All right. Now, we now have a uniform distributed load, which we will convert to a point load. 7.5 multiplied by 2, that is 15. Do you understand? And that 15 now, if you take that moment now, it's going to act at just 1. That is, it's going to be divided by 2, 1, 1. So we are going to have 7.5 multiplied by 1. So, 7.5 multiplied by 2, then multiplied by 1. That is 15. So, and which is going to be minus. So we are going to have minus 15 equals to, so if you press this in your calculator, what do you have? We have a negative 7.5 multiplied by 4. That is negative 30. And then negative 30 minus this, that is negative 45. And 22.5 multiplied by 2, that is all right. So the bend moment at D is what? 0. Don't forget, I told us that we have to be careful with point D. The reason is this. Now, if you now check point D now, then I had another moment there, which is a what? Which is an anti-clockwise moment, right? All right. So now you have to be careful. Now, the moment at point D is what? 0, right? Now when they now had this moment, this other moment to it, which is 15 kilonewton meter to it. So it means we are going to add 15 to what? 0. So it means that our moment is going to change from 0 to what? To 15. Exactly. So we are going to add this 15, which is going to be what? Positive. Because it is going what? In this what? Anti-clockwise direction. And based on the coordinate that we have given, we said this coordinate here, this moment here is going to be what? Positive. So if we add 15 to 0, we are going to get 15. Please take note. So if you want to do the bend moment at point D, you are going to go to 0 first. So from 0, it's going to change to what? To 15. All right. So now the next thing we are going to be doing is the bend moment at what? At F. Bending moment at point F. All right. So if you stand at point F now, the first thing we are going to have there is RB multiplied by what? By 4, right? RB multiplied by 4, that is 22.5. 22.5 multiplied by 4. All right. Then minus 7.5 multiplied by total distance, that is multiplied by 6, right? All right. Minus 7.5 multiplied by 6. All right. All right. Now, so if you look at this again, we have a uniform distributed load here. So if we convert that to a point load, 7.5 multiplied by 4, that is 30. 30 is going to act at the center, that is 30 multiplied by what? By 2. So it's going to be minus 30 multiplied by what? By 2. All right. And also don't forget now, we now have a moment here. Do you understand? This one too is also a moment, which is going to be what? Positive. So it's going to be plus what? Plus 15. So this will be equals to what? This will be equals to, this carefully, you are going to get nothing but 0. Yes. So you are going to get nothing but 0. All right. So now, the next one is this. The bend moment at point A. All right. You can take the bend moment at point A from this point to this point. Do you understand? We arrive at the same answer as taking the moment from this point to this point. Do you understand? Because I will say clockwise moment from physics is equal to what? Anti-clockwise moment. Exactly. So you can take the moment from this point to this point, must also be the same as taking the moment from this point to this point. But if you look at this now, taking the moment from this point to this point will take time. Do you understand? Though you arrive at the answer, but you cannot compare that with taking the moment from this point to this point, which is very fast. So I'm going to be taking my moment about that point. This is the bend moment about point what? Point A will be equals to what? Now, but here now, if we are doing that, you have to be careful. We are going to be taking note of this condition here. Exactly. Because there we are going to be having what? A downward force, which is going to be what? Negative. So it's going to be what? 7.5 multiplied by what? It's multiplied by 2. That is minus 7.5 multiplied by 2. So we are going to have minus 7.5 multiplied by 2, which is going to give us what? It's going to give us minus 15 kilonewton meter. All right. So please, all the units for our bending moment is kilonewton meter. Please take note of that. Kilonewton meter. All right. So including this one too is kilonewton meter. All right. So now we are going to be drawing the shear force diagram and the bending moment diagram. Stay tuned. That is, every point here we are going to draw them down that we have load downwards. Then we are going to draw the reference line for our shear force and the reference line for our bending moment. All right. So here are our reference lines. All right. So the first one is the reference line for our shear force. While this other one is the reference line for our what? Our bending moment. All right. So now let's start with the shear force. All right. The shear force at point C is what? Negative 7.5. So we are going to have 7.5. Let's just take our 7.5 to be somewhere around here. All right. So, and between C and B, we don't have any force. So it's going to be a constant line. It's going to be a constant line. All right. So let's just write here 7.5. But don't forget, above is positive, below is what? Negative. So there's no need for me to write negative here again. All right. And if you want to write that, you can write that. And you also put the unit. But I'm just trying to maintain my space. All right. So at point B rather, our shear force is what? 15. So it moved from this point to what? To 15. So let's just take this point to be what? To be 15. All right. All right. So this is 15. All right. So now, between B to D, we have the shear force for D, right? Which is what? 0. All right. So now it means that our shear force move from this point to what? To 0, right? All right. And from this point D to F, we have negative 15. So it moved to negative 15. And don't forget, if we have a uniform distributed load, we are going to be drawing, representing that with an inclined line in our what? Shear force diagram. So this is our 0 at point D. So we are going to draw this line from to this point. So it's going to be like this. All right, so that is it. All right. So now that is point D. So and the shear force at our point F is what? Negative 15, right? So let's take this point here to be our what? Negative 15. Let's take this point here to be our negative 15. All right. So again, we are going to be joining these two lines by an inclined line. All right. All right. So now, the shear force at point A is what? Is 30. Sorry, is 15. But between F and A, we don't have any force there, any load. So it's going to be a constant line. It's going to be a constant line. All right. So at A now, we have our shear force to be what? 15. So we are going back to 15. So if we do this, our 15 is going to fall at this point. All right, so it's going to fall at this point. This is 15 here, this is 15 here. All right, so this is 15. So now, and from A to E now, from A to E, our E is what? 0. So we are going to be drawing this point to this point, and we have a uniform distributed load. It's going to be what? Inclined. So we are going to join this point to this point with an inclined line. All right. So this is our shear force diagram. You can decide to shade it. All right. All right. So this is our negative part. This is our positive part. This one is our negative part. This is our positive part. All right, so that's it. Now, the next thing we want to do is our what? Is our bending moment. So the bending moment at point C is 0. So this is 0 here. All right. And the bending moment at point B is what? Negative 15. So these are negative 15, point B. So our negative 15. Let's put it somewhere. Sorry, negative 15 will go down. The highest number there is 15, right? Sorry, the highest number here is 15, and the least number here is 15 as well. All right. So let's take this down. So we are going to have here, let's take this place to be our what? Negative 15. Negative 15. All right. So now this is our point B, which is what? 15. Negative 15. So we are going to join this line to this line. So every straight line in our shear force diagram will be replaced with a what? An inclined line in our bending moment diagram. So let's join this point to this point. All right. So now we have our bending moment at point D to be what? Now if you move, the first value we calculated is what? 0. So now it means that the bend moment move from this point to what? To 0, right? So now, and don't forget, we have a uniform distributed load. We are going to be replacing that with a what? With a what? A curve. Do you understand? We are going to be replacing that with a curve. So we are going to have from this point, let's just replace this point. All right. So that is a curve. All right. So now, from point, it moved from negative 15 to what? To 0. And from point 0 now, on the now, they now had this moment, which is 15. So 0 plus 15 here is what? 15. That is to move to what? To 15. So let's put our 15 to be at this point. So let's say this is our 15. So we are going to take this line upward. All right. All right, so that's it. Now from 15 now, it moved to, that is the bend moment at F. The bend moment at F is what? 0. So it moved to what? 0. So don't forget it's a uniform distributed load. We are going to bring back our what? Our curve. So we are going to have a curve here. We're going to have a curve here. All right. So now from this F, then from this F now, then we move to what? To A, right? So we move to A, and our A is what? Negative 15. So our A is negative 15. So here we have negative 15 here. We have negative 15. So let's take this point to be our negative 15. Or let's put it somewhere here, negative 15. All right. So now, since we have just a straight line here, so we are going to be replacing it with what? An inclined line here. So we have an inclined line. All right. So now, the bend moment at point E, we did not calculate that. And we did not calculate that, and the reason for that is, if you look at this beam carefully, you observe that this beam is an overhanging beam. So the bending moment at the free end of an overhanging beam is nothing but what? 0. So as you can see, the bending moment at point C is 0. Bending moment at point E is also what? 0. Do you understand? But if you still want to calculate that, you can do that. You just stand at this point, then you take all your moments to this side. Is that clear? So the bending moment, but once you have an overhanging beam, you don't need to calculate the bend moment at the free end. You just know that that is always going to be what? 0. So the bend moment at point E will be equals to what? 0 kilonewton meter. All right. So now, and again, we have a uniform distributed load here. So we are moving to what? To 0. So we are going to be joining this curve with this point. All right. All right, so that's it. So now we can therefore decide to shade. So we can therefore decide to shade. We are going to have this. Right. All right. All right. So here is our negative part. Here is also negative part. So here is positive. All right. So here is our shear force diagram. And here is our bending moment. All right, diagram. So here is the solution to the above question. I believe you've learned from this. Stay tuned for more complex, and we are going to try to simplify the questions. Thanks.